The basis of our project is how does ipilimumab blockade the immune checkpoint. This presentation is presented by RJ, Eric, Kim, and myself. Our project revolves around immunotherapy, which is the branch of oncology focused on using the human immune system to destroy the cancerous tissues. There's 4 types of immunotherapy. Non-specific immune stimulation is just a general boost to the T cells themselves. Adoptive cell transfer brings in cells from an outside source with the goal of bringing up efficiency. Vaccination strategies put in outside cells around the tumor to bring the T cells to the tumor itself. And our project revolves around immune checkpoint blockade.
Immune checkpoint blockade, or immune-mediated molecules, could be used to activate a T cell to recognize the foreign cancerous substance or cells, such as the advanced melanoma. The CTLA4 site, which usually competes with CD28, can be activated by the molecule, also known as Yervoy, and this was approved by FDA treatment for late melanoma. In this experiment, they had an in vivo intravenous injection of the inhibitor to 75 subjects with grade 3 and 4 melanoma over the course of 3 weeks. The results of the study gave 86% to experience complete resolution, while 3% improved to grade 1 cancer, and only 11% did not improve at all. Further research of this drug can be used for the approval of other types of cancer, such as bladder cancer.
So to completely understand how ipilimumab acts, we first need to look at T cells. So T cell activation requires 2 things. It requires the binding of T cell receptors to antigens within the major histocompatibility complex, and it also requires the binding of T cell CD28 receptors to B7 molecules, which are found on tumor cells and presented by antigen-presenting cells. So once activated, a different receptor called cytotoxic T lymphocyte-associated antigen 4, or simply CTLA4, is able to outcompete CD28 receptors for the binding of B7 molecules, and thereby inactivate the T cells, preventing them from being overly active. The CTLA4 receptor is a very important receptor, and it prevents several autoimmune diseases. Another receptor signaling system contributing to the inactivation of T cells are programmed Def1 receptors, PD1. These are expressed on the surfaces of T cells. When PD1 receptors bind to the PDL1 ligands expressed on antigen-presenting cells, it inhibits all T cell activity. So, to stimulate the immune system, Bristol-Myers Squibb developed ipilimumab. So on the left here is what I just previously mentioned, with these receptors shown here. And ipilimumab binds the CTLA receptor found here, and it prevents it from binding to B7. So that allows CD28 to remain bound to B7, which allows T cells to remain constitutively active. Recently, and in the near future, ipilimumab has and will be used in combination therapies with other drugs. In this figure, we can see the mechanism of action for ipilimumab and nivolumab in their role for activating T cells. Nivolumab is an inhibitor of the PD1 receptor. The nivolumab prevents PD1 from binding to PDL1, which thereby prevents T cell programmed cell death and helps to keep T cells active. Both of these drugs are capable of immunostimulation, and they facilitate the T cell mediated cytotoxicity of cancerous cells.
By permanently activating T cells, the body will not be able to turn off its immune response. This overactivation of the immune system can lead to fatal adverse reactions, the most common including enterocolitis, hepatitis, dermatitis, neuropathy, and endocrinopathy. The most common side effects include fatigue, diarrhea, nausea, headache, weight loss, and insomnia. Because this drug has been shown to cause fetal harm, it should not be used during pregnancy. It has also been proven to be safe or effective for pediatric use. Although there seems to be a lot of disadvantages to using Yervoy, there is an increased survival rate in patients who use this drug, so the benefits largely outweigh the risks.